We're going to start a series of videos about factoring polynomials. This is one final operation on polynomials that's very important all across algebra and even going into pre-calculus and calculus. Factoring a polynomial simply means that you're writing it as the product of smaller factors. So in a lot of ways, it's the reverse of what is happening when you multiply a polynomial. If I have a polynomial that looks like this, 2x times x plus 3, and I multiply it, I'm moving in this direction. If I start with an expression that looks like this, 2x squared plus 6x, and I'm asked to factor it, I'm moving in this direction. I'm undoing that multiplication to find the smallest factors that multiply together to make up this larger polynomial. All right, so factoring is the opposite of multiplication in a lot of ways, and one way to get good at factoring is to become really comfortable with multiplication and to begin to recognize patterns in multiplication. We'll talk about some of those later on. There are many different strategies or tools for factoring, and so there's no one-size-fits-all method when it comes to factoring. Rather, there are different strategies that you can apply in different contexts and to different polynomials. Sometimes you'll use a combination of strategies to factor. The most basic strategy is called factoring out the greatest common factor, and this should always be the first approach to any factoring problem, is to attempt to find and factor out a greatest common factor. I want to talk a little bit about what a greatest common factor is, and then we'll show how to factor it out of an expression. So the greatest common factor of two or more terms is just the largest amount that evenly divides all of the terms. Some people might say it's the largest amount that the terms have in common. So example, the GCF of 2x squared and 6x. I think what's the largest amount that evenly divides that? Well, 6 and 2 are divisible by 2, right? X squared and x are both divisible by x. So the GCF is 2x. And that's exactly what we see happening here in this factoring, which we'll look at in a little bit. Let's practice finding the GCF of some terms. So let's find the greatest common factor of 12x squared, 8xy, and 4xy squared. Remember, that's the largest amount that evenly divides all of these terms. And I can consider the coefficients separately from the variables if I like. So think about 12, 8, and 4. What's the largest number that divides all of those? They're divisible by 2, but that's not the largest number. They're divisible by 4. So in our GCF, we'll have a 4. Let's look at the x terms. There's an x squared, an x, and an x. So what's the largest amount that can be divided out of all of those? Well, the answer is x. Finally, let's look at the y terms. There's a y, here's a y, here's a y squared. What's the largest amount I can take out? It's y. I can't take out a y squared or divide out a y squared because these don't have a y squared, right? So I'm limited by the factors that all of the terms have in common. Our GCF here is 4xy. If you want a surefire way to find a GCF, one approach is to write the prime factors of all of these numbers and variables, and then to multiply the prime factors that all of the terms have in common. I'm not going to show that in this video, but I'm sure you can find other examples of that if you go looking for it. Finally, let's apply the concept of factoring out a GCF to a couple of examples. So I want to factor this trinomial. Let's identify the GCF first. Let's see, the largest common factor between 14, negative 6, and 2 is 2. And then I have x to the fourth, x cubed, and x squared. So the largest common factor is x squared. That's the largest thing I can divide out. We write this in front. It doesn't disappear from our expression when we factor out a GCF. We write it in front. That's one of the factors. And in parentheses, I'll write the other factor, which is the result of dividing all of these, term by term, by the GCF. So I imagine 14x to the fourth divided by 2x squared. That's going to be 7x squared. Negative 6x cubed divided by 2x squared, that's going to be minus 3x. And finally, 2x squared divided by 2x squared, that's positive 1. So here's our factored form of this polynomial. 2x squared times this trinomial. I can check my work by multiplying. Remember, factoring is the opposite of multiplying. So if I multiply this out term by term using the distributive property, I should reach this trinomial. One more example. Let's identify a greatest common factor here and factor it out. I have negative 6, positive 54, and negative 12. Do some checking on that, but those are all divisible by negative 6. And I'm choosing here to factor out the negative sign as well so that the first term is positive. When I look at the variables, I have a cubed, a squared, and a. The largest factor that can divide out of all of those is a. So my GCF is negative 6a. That's one of our factors. The other factor in parentheses is the result of dividing all these by negative 6a. We divided that out in front of the expression. That's the reverse of distributing. So negative 6a cubed, divide out a negative 6a. What's left over is an a squared. 54a squared, divide out a negative 6a. I'm going to have minus 9a. And finally, negative 12a, divide out negative 6a, is positive 2. So here's my result after factoring out the GCF. These represent the same expression. This one is just in factored form, right? Factoring means breaking a polynomial down by writing it as the product of factors, and that's exactly what happened here. It's a product of the factors negative 6a times the other factor, a squared minus 9a plus 2. So that's our first strategy for factoring. Identify the GCF and factor it out of the whole expression.